What's going on, gangsters? Welcome to your 171st Android tutorial for the new Boston. What we're going to get into is actually start developing some kind of object that we can display within our OpenGl class here. And I know I told you guys we were going to develop a cube, but as for now, I don't want to jump into 3D. I just want to get the basic concepts. You know, developing a cube is so old school. It's like so square, you know. But I want to go into the basic concepts and just develop a triangle, 2D object, and then we'll get into the 3D since it's pretty much the same but a little bit different. And what I'm going to do is just kind of talk about some of the concepts using Blender here, which is a 3D modeling software, animation software, all that good stuff. And it's free, so if you guys are interested in that, I'd recommend Blender if you don't want to spend the money on like 3D Studio Max or anything like that. And as you can see here, we have a cube, which again we aren't developing. We're developing a square, or I'm sorry, we're developing a triangle. But with OpenGl, just some of the concepts that we can do is we can set the actual camera view. So if this like gray area here is our phone's device, we can say, hey, we want the camera to be closer to the object here, so you know our object appears larger. Or we can say we want our camera way back here, so our object's smaller. We can also scale the actual object itself, all that good stuff. So that's why we set up kind of the renderer class. That's going to handle some of those type properties that we're going to work with. But now let's just get into the basic concepts of 3D programming and what we're going to need to know. Again, here's just a cube, and we can rotate around it. But that's a 3D object. So as for now, we're just going to work with 2D, and I'm just going to switch to like the front view here. And the cube has 4 vertices. A vertice is just basically a point. Like a point here, a point here, a point here, and a point here, and then it's connected and filled and it's shaded, all that good stuff. What we're going to do is we're going to create a triangle, so we're only going to have 3 points. And how this works is we have an x-axis and a y-axis. The x-axis goes to the right is positive, to the left is negative. The y-axis is positive up and negative down. Which we'll get into a little bit later. But just for example, this point right here would be like -1 in the x direction, comma, +1 in the y direction. So that would be this point. So we're going to create some vertices in this tutorial in Eclipse. But you know, that's just how this is going to work. And again, just like for example, this point is 1 in the x direction and 1 in the y direction. Then we have 1 in the x direction, -1 in the y direction, etc. So let's just jump over to Eclipse. Hopefully you guys kind of understood what I was trying to explain there. And again, I told you guys we're going to create a triangle, so you need to set up a new class called GL Triangle Example, or EX. And probably all we're going to do in this tutorial is set up some of those vertices or some of those points that we're going to connect and fill in later. So how we're going to do this is we're going to create a float array. So we're just going to say private, because again, since we have this triangle class, everything's going to be, for the most part, private in here, because we aren't going to allow other classes to change some of these vertices and stuff like that. So we're going to set these vertices to private, and it's going to be of the type float, and we're going to say vertices. And again, we just put those brackets to say that we're having a list or an array of some sort. Then we do our opening bracket, and let's define the points that we want to map out. And also we just are going to finish our statement here, and then we're going to define the points. So for example, we want our triangle to have a point of like here, here, and then right in the center up here. And we're going to have to remember some of these points. What we're going to do is we're going to start at this top point here and work our way around you know, clockwise like that. So let's develop our first vertice in Eclipse. And so again, the first, or the top part of the triangle, the x direction is going to be 0, and we're just going to say f for float. And the first, you know, the y direction is going to be a +1 because it's going up. So we're just going to say 1f as well. And then, you know, we can set up our next vertice here as well, or like, you know, 1 or whatever. But you know, it gets kind of confusing when you look back at your code and all that stuff. So what we're going to do is we're just going to hit enter and start a new line, so we know, hey, yeah, we're working with a 2D object with the x and the y direction, and that's our first point. So you can even leave a comment here like 0.1 or something like that. or actually this would be 0.0, because again in computers you always start with 0, 1, 2, etc. And then we're going to create our second point, so that's going to be at the reference 1 in the x direction and comma -1 and in the y direction. Then we can again leave a comment like 0.1. For our last point, it was -1 in the x direction and -1 in the y direction as well. And we're just going to say 0.3. And also we have to, I'm sorry, I forgot to set this equal to what we want. So we're just going to set this equal to this bracket here. So yeah, so that's why we're getting those errors. Because again, when we define an instance of a class, we have to set it equal to something. So these are 3 points again. And why did I put 0.3? Just messing up everywhere. And that's 0.2. So again, let's just look at these. Just a quick tutorial. Nothing too complicated, but again, just to understand these principles of 3D programming. Our first point is 0 in the x direction, so I'm going to try and show it in Blender here, and 1 in the y direction, so like right here will be our first point. And then the second point will be 1, -1, so it's going to be like 1 and then -1, which will be right here. Same corner as that square for the most part. And then for our third point, it's going to be -1 in the x direction, -1 in the y direction, so right here. And then what we're going to do is we're going to connect it and then fill it in and all that good stuff. So that's pretty much it for this tutorial, guys. Just a basic introduction to 3D programming, or actually I should say 2D programming at the moment. But there we go, and I'll catch you guys in the next tutorial. Have a good one. What's up, guys? Welcome to your 172nd Android tutorial for the new Boston. What we're going to do is still work with this GL triangle example class. And all we've done so far is just basically set up a float, a list of floats, and there's no relation to OpenGl or anything like that. So the first thing that we need to do is we need to set up something called a float buffer. Because again, a few tutorials ago we used buffers, and they just are a way that we can render stuff to the screen. So we're going to call this like our vertice vertbuff, maybe, for vertice buffers, and we're basically going to relate these vertices later. And we want to set this again just to be a private variable for now. And again, we have to add our imports. And also for this class we're going to need a constructor, because again, when we create an object we want to call the constructor and set everything up. So that's what we're going to set up real quickly, and this one's going to be public so other classes can use this constructor. And again, when we create a constructor, it has to be the same name as our class name. So triangle EX, and this isn't going to have any parameters within it. We could probably grow on that later, but we're just going to set that up. And within this triangle, what we're going to have to do is we're going to have to create a vertex buffer and a byte buffer, because the byte buffer is going to tell our application how much space we're using, how many kilobytes or bytes that we're using. And for each float that we use, that takes up 4 bytes. So our float list here has 6 different floats within it. So we're going to have to locate 24 bytes within our buffer. So what we're going to do is we're going to set up our byte buffer. I know it's kind of confusing maybe a little bit for now, but we're just going to set up that byte buffer. We're going to call this bbuff. Going to set this equal to the byte buffer class and use the method .locate direct. And again, we just have to, it takes an int of the capacity that we're going to be using. So again, like I said, it's 24, but in case we add more vertices to this float array, we want to be able to handle that and tell our update our byte buffer and say, hey, we're using more memory than just 24. So we're going to relate to our list that we created called vertices, and we're just going to say .length. That's going to return how many floats are within our list, and as for now there's 6, so that's going to be 6. And for each float we use 4 bytes, so we're just going to times this by 4. So that's basically telling our buffer, this is how much we're using, which is 24 bytes. And then what we're going to do is we're going to set up the order within our byte buffer, and so we're just going to say bbuff.order, and you can see as it takes within its parameters, a byte order. So we're going to click that one. And all we're going to say is we're going to relate to the byte order class. So byte order, and we're just going to say dot native order, and that's just going to give us the native order for a byte buffer. So now what we need to do is we need to relate to this vertice buffer and kind of make the connection as well. So we're just going to say vert buffer, or vert buff I should say, and we're going to set this equal to our byte buffer, which we called bbuff, dot as float, because there's different types of stuff that lists that we can have within a buffer, but since we're using floats, we're going to use this as a float buffer. And I spelled vert buff wrong, sorry. So set that up, and then what we're going to do is we're just going to say we need to put our list within this vertice buffer. So it knows that we're working with floats as for now, and we're just going to say vert buffer, or vert buff dot put, and then we have to put our float array in there, which we called vertices. And then all we're going to do is we're going to relate to our vert buff and tell it what position we want to start. So vert buff dot position, and we're going to start at position 0 or the top of our triangle. So that's pretty much it for this tutorial. I know it's kind of confusing as of now, but it'll sink in what we're actually doing in the next few tutorials. But I'll catch you guys then, and have a good one. What's up, guys? Welcome to your 173rd Android tutorial for the new Boston. And what we're going to do in this tutorial is kind of the same thing that we did in the last tutorial, except instead of working with vertices, we're going to be working with indexes. So what we're going to do is we're going to set up a private, instead of a float array, we're going to set up a private short array that's going to basically hold our indexes, or our specific points. So we're just going to call this point index array or list. What we're going to set this equal to is basically we have 3 points, so we're just going to say 0, 1, and 2. Now we have to set up a buffer for our index points. And again, I know right now you guys might be lost about what we're doing, but it will wrap together and tie together, and you'll see it, what we have done, and everything will for the most part make sense. But what we're going to do is we're going to set up a private short buffer instead of a float buffer, since we're working with a short list. So we're going to say private short buffer. We're going to call this our point buffer, something like that. And then again, we're just going to add our imports. And now again, within our triangle constructor, we're going to set up our short buffer for the most part to relate to our indexes. So just give us a couple spaces here, and we're again set up a byte buffer. Call this our point byte buffer, or point B for byte and buff, something like that. And we're going to say again relate to the byte buffer class, and we just gotta tell the buffer how much how big the capacity needs to be, what it can handle, how many bytes we're working with. And when we're working with shorts, a short is 2 bytes. So as a float was 4 bytes, all we're going to do is relate to our list of our index list, get the length of that, and then times it by 2. So it's pretty much the same concept. We're just going to say p index dot length times that by 2 for 2 bytes per short. And then we're going to again say our point buffer, or we're going to say our point byte buffer, set it to native order, again just by referring to the byte order and saying dot native order. And again, all this line is doing, we're going to be calling a GL pointer function on these buffers, and in order to do that, we need to say it needs to be in native order. So basically the garbage collector won't be able to access this or move it or dump it. So that's what we need to set up this native order code, and that's all that's doing is relating to again the byte buffer that we set up. And now what we're going to do is we're going to relate to our index buffer, which we called point buffer, or pbuff, and we're just going to say pbuff is equal to our pbbuff, or point byte buffer, and we're just going to say dot as short buffer, because again we aren't working with a float buffer, we're working with shorts now, so we're just going to say we need a short buffer. And there we go. Now what we're going to do is again we're just going to say we're going to relate to our short buffer, and called pbuff, and all we're going to do is say dot put, and then we have to tell it, you know, what we want to put in there, and we're going to relate to our point index list. And then all we're going to say is move the position to 0 as well, and that's pretty much it. And we're going to do one more thing kind of like this for our textures, relating textures to a triangle, something like that. But we'll get to that in, again, probably a few tutorials so you guys actually can see what these are doing when we get into the code, and then we'll come back and maybe do like a texture one if we have time, and then you guys can, the next time we go through this type of thing, you'll understand everything that's going on, why we, you know, set up these buffers and all that good stuff. But again, as for now, that's pretty much all we're going to do in this tutorial. Pretty simple as well. All we did is set up a new byte buffer that's going to be a short buffer, and handle our index or our points like point 0, point 1, point 2, instead of handling actual you know, our actual all of our x and y values of those points and all that stuff, which we did in the previous tutorial with our vert buffer. And I'll show you guys how we're going to use these you know, as we go through this OpenGl series. But as for now, that's probably it. I know it's kind of a boring tutorial, but thanks again for watching, guys. I'll catch you in the next one. Have a good one. What's up, guys? Welcome to your 174th Android tutorial for the new Boston. And what we're going to do is basically finish up, or, you know, for the most part, finish up our triangle class here. I bet some of you guys are like, finally, I didn't think it'd be so like complicated to draw a triangle. But yeah, we're almost done, guys, so don't worry about that. And what we're going to do is we need to call or create a method that's basically going to draw to our GL10 object. And so it's going to be pretty simple. All we're going to do is create a new method within this class called public void draw, and it's going to take a GL10 object within it, and we're going to call it GL just for simplicity. And then we're just going to, you know, add our imports, and let's get into it. Basically, we can define certain things. We can define how we want to draw our triangle, you know, which side of the triangle we want to display. We can disable the back side or something like that. So that's what we're going to do within this draw method, is just get everything set up, and this is the method that we're going to call within our render class. Because again, our constructor is going to set up basically you know, the base stuff that we need, the buffers, and then we're going to access them through this draw method. So the first thing that we're going to do is we're going to relate pretty much to our GL object that's being passed in of our draw here the whole time. So what we're going to do is we're going to say GL, and first we need to connect all of our points. So what we're going to do is we're going to say we want to refer to the GL front face. That's the face that's facing the front, you know, and we got to tell it how we want to connect these points. Again, we started at the top of the triangle, the second point's over to the right, third point's to the left, and that's how we're going to connect our triangle, is clockwise. So what we're going to do is we're going to relate to the GL10 class dot GL C, and we have counterclockwise or just CW for clockwise, and that's how we're going to connect ours. That's just, again, just telling which face we want to face front. Obviously, if we did counterclockwise, then the back would be facing us, if that makes sense. But we want to do the front facing us, and that's what's going to render to the screen. So there we go. We have our clockwise connection and all that good stuff set up. And now what we need to do is we need to basically relate to the client state, enable it for vertice arrays, because again, we're working with this float buffer that's basically, you know, a vertice array type thing, because, you know, we have float values within that buffer. So what we're going to do is we're going to say GL.GL enable client state, and as you can see, it takes an int array within it. But again, we're just going to relate to the GL10 class, and you're going to get familiar with relating to this class when you guys start programming in GL or OpenGL. And all we're going to do is say dot GL underscore vertex array, and that's just going to allow us again to use a vertex array, and we're just enabling the client state. And all we're also going to do is give us a couple lines here, and we're just going to say our GL object GL disable client state, because anytime we enable we want to disable it. Again, we're just going to say GL10.GL underscore vertex array, because that's what we're disabling now. And we're going to write some code in here, obviously, but again, just to make note, you guys want to enable the client state for a vertex array and also disable it. And again, I told you guys we were going to relate to a pointer of some sort. That's why, again, we had to use this line of code that is in native order, so our garbage collector won't, throw it away. So what we're going to do is we're going to say GL, again, pretty basic here, and then just GL lowercase like that, sorry. And then we're just going to say vertex pointer. Again, the pointer is what we need. Takes in 4 things within its parameters. We have the size, which is how many dimensions we're working with. And again, we're just working with the x and the y value, so that's going to be equal to 2. The type, the stride, and the buffer. So again, that's the buffer we set up. And so first, again, for the size, we're working with two-dimensional objects, so we're just going to say 2 there. For the type, we need to say it's a float, because again, if you guys remember, our vertbuff is a float type buffer. So we're going to relate to the GL10 class again and just say GL underscore float. And the stride we're going to set to 0. And what the stride is, let's zoom back up to our vertices array here. If we had something else, like another dimension maybe, or like a color or something, some other kind of reference in here. For example, we wanted to skip out one of these things. Basically, you use the stride to skip over this third and then start our new vertice. But since we don't have anything we want to skip over, we're going to set our stride to 0. Our pointer is going to be our vertbuff or vertice buffer, and so we're just going to say vertbuff. So there we go. Now we kind of have reference to, again, our vertbuffer that we set up and all those coordinates that we put within the buffer and all that good stuff. And we have to add one more line, but I kind of wanted to explain that last line. It's pretty important for actually drawing our triangle. So I'll probably end this tutorial now, and I'll catch you guys in the next tutorial where we're going to basically finish this triangle class for the most part. We might come back and do texturing and all that good stuff, but we'll get our basic triangle set up. And I'll catch you guys in. Hope you have a good one, and see you later. What's up, guys? Welcome to your 175th Android tutorial for the new Boston. What we're going to be doing in this tutorial is basically getting everything set up to actually draw a triangle onto our emulator, finally. It might take one more tutorial before we actually can see it, but we're at least going to draw to it. So, in that line of code that I wanted to show you guys, or why I didn't type in the last tutorial, because I wanted to try and find some pictures of how it would connect our vertices using these different modes for the most part, but I couldn't actually find any pictures online, so we're just going to wing it, and I'll try and explain it to the best of my ability. But all we're going to do is, again, within our enabled client state, we're just going to relate to the GL object being passed in again, and we're just going to say glDraw, and we have 2 draw methods, arrays and elements. And we're going to use the elements because we have basically a index buffer set up, again, that ShortBuffer, and that's what we're going to relate to with the DrawElements. With the draw arrays, you don't actually need a buffer, as you can see within the parameters, but we want to get a little bit more specific to draw the way that we'd like, so we're going to use the DrawElement. And the mode is what I wanted to show you guys. Basically, it's going to connect our points or vertices in different, or indexes I should say, because again we created these 3 points out of the coordinates for the most part, and it's going to connect those points different ways. So again we're going clockwise, starting at 0, 1, 2, and we can connect those either by like creating a line. We can connect those with like a line where it connects the last and the first point that we started with. We can connect it with actually just building a triangle, which we're going to use, and there's also other ones like triangle fan and some other options that you guys can use, but again I couldn't find any pictures on that, so sorry about that. But again, all we're going to do is we're going to relate to our GL10 object or class, and then we're just going to say GL underscore triangle. And yeah, we have a triangle strip, a triangle fan, But we're just going to create one triangle. You guys, if you can find it, like leave a comment in the video or something to help other people see what these actually do. Basically, a strip is if we had like 10 points, it'd just like start at this point, strip it, or go like a zigzag down all those points and create triangles that way into a strip. A fan, if we had like a point here, like this is our point 0, then we have point 1, 2, 3, 4, 5 all around it. It'd create triangles based off that center point. But since we're just creating one triangle, we're just going to say we want to just build a triangle out of it. And then what we want to do is we want to tell them how many points or indexes we have. Again, our index array up here has 3 points, so we're just going to say 3, or just to be a little more program cautious, we can just say p index dot length. And for the type, again, we have to define what type our buffer is, and again, it's the short type that we have up here. And just like the last time we set up this pointer, we referred to that as a float, so we have to tell that this DrawElements method that we're working with shorts. So all we're going to do is just say our GL10 object, or class, why do I keep saying object, dot GL underscore unassigned short, or unsigned short, sorry. And we're just going to click that, and then that's going to define what type we're working with. And then lastly, we need to set up our buffer, which we called pbuff. And there we go. We're pretty much done with that line. And all that's doing is going to say, hey, we're working with 3 points or 3 indexes, and we're working with a short, and this is basically the order that I want, and I want you to get to draw a triangle. Again, going counterclockwise, all that good stuff. What's up, guys? Welcome to your 176th Android tutorial for the new Boston, and we're getting close to actually, putting our triangle on the emulator there so we can see it. We basically have set up everything that we need for a triangle class, so we're just gonna go over to our renderer class, because this is where all the magic's gonna happen. And what we need to do is first reference that triangle somehow, so we're just gonna build a constructor for this class as well, because again, our activity is calling this class, so we want to make sure we have a constructor as well that sets up our triangle. So we're just going to say public GL render ex, and then all we're going to do is set up our triangle within here. And you gotta make sure you spell it right, obviously. And so we want to set up a triangle instance as well. We're going to set this to be private. We're just going to say GL triangle ex. We're going to call it try, something like that. Then what we're going to do is we're just going to set our try within our constructor equal to a new triangle, or new instance of that class. And there we go. Now we have our triangle object within our renderer. And again, we created a draw method within our triangle. So within our onDraw frame, all we have to do is basically say, well, I shouldn't say all, because as you'll see here in a second, it won't actually print this to the screen yet, but it is actually drawing it in OpenGl. So what we're going to do is we're going to refer to our triangle and just say dot draw, and we're going to pass in again the GL10 object that we're being passed in within this method. So it's pretty simple. Again, we get this GL object that's being passed in, and we just pass that into our triangle to create our triangle and set it up and all that good stuff. We have that draw method within there, so that's what that's doing. But even if we run the application right now, we just get all red. We can't see anything. We don't know where our triangle's at, all that good stuff. And the problem is let me go back to Blender. And again, we are drawing our triangle, but we might have a different perspective. For example, our camera right here is looking at the square, but let's say we move to a mode where our camera is looking off into the distance over here instead of at our actual square. So that's kind of what's happening. So in the next few tutorials, we're going to learn how to glue the camera to look at a certain position. We're also going to set up our viewport so we know how how wide it is and set up our projection so it's not all skewed. But yeah, thanks again for watching, guys. I know it was a pretty simple tutorial where we just set up our triangle and drew it. But again, hopefully you guys understand a little bit more about the GL, just because it seems like it should be printing to the screen, which it is, but we can't actually see it because we don't know where our camera is looking and all that good stuff. So I'll catch you guys in the next tutorial. Hope you have a good one, and see you later. Alright, and also because we didn't really talk about too much, I'm just going to add a little bit more to this tutorial. So what we're going to do is we're going to basically when we create a render of some sort, or a GL, OpenGl, class, it loads it with some default stuff that might even hinder performance. So we're actually going to give us some space within our onSurface created, and we're just going to say gl.disable, because we don't want everything that they give us. Sorry, it's GL disable, and what we're going to disable is the dither. So we're going to relate to the GL10 class dot GL underscore dither, and that's just going to speed up our performance a little bit, and not worry so much about the quality, but worry a little bit more about the performance. And also we can just elaborate a little bit more by saying gl.gl hint, and we have to reference a target, so we're going to say gl 10 dot gl underscore perspective correction hint, and then for the mode what we're going to do is gl 10 dot gl underscore fastest. That's just going to again boost our performance a little bit more and not worry about the quality as much. So there's just a quick add-on to this tutorial. Again, you guys might want to just copy this this dither line and put it within your onDraw method or onDraw frame method or something. But there you go, and I'll catch you guys in the next tutorial, and hope you have a good one. See you later. What's up, guys? Welcome to your 177th Android tutorial for the new Boston, and finally we're gonna see our triangle on our emulator. I know I've been telling you guys that a few times, but hopefully we'll be able to go through this tutorial pretty quickly so we can see our triangle there. And what we're going to do is we're going to set up this method onSurfaceChange. Again, this is our renderer class, and we need to set up the viewport. We need to know how big our viewport needs to be, and that's why it passes in this width and this height. So we're going to reference those to create our viewport and all that good stuff. So again, we're going to refer to the GL10 object that's being passed in. We're just going to say GL viewport, and it takes X and a Y and also a width and height. So our initial X is going to be 0 and our initial Y is going to be 0, which will be the bottom left corner of the emulator, and then it's going to go over to the width that we're getting passed in into the height. So that's basically going to set up everything that we have available to us. Our whole activity screen is going to be full. That's going to be our viewport, and then we're going to create a ratio of the width divided by the height, and I'll show you why we're going to need that, but it's going to be a float, and we're just going to call this ratio. Set this equal to float value, passing as a float, and then we're just going to say width divided by height. And so again, that's just a ratio of our width to our height, because when our our device changes, we want to have the ratio the same, whether it be in portrait or in landscape mode. So that's what we're going to need this ratio for. We're also going to set up what matrix mode we want, and we're just going to say GL matrix mode, and we're going to set this equal to again GL10 object or GL10 class dot GL underscore projection. And that's just kind of the way that we want to view it. We want it to be a projection of some sort. And then when we create this kind of a GL matrix mode, all we need to do is we gotta say GL load or identity. We just need to say GL load identity, and that's going to refer to kind of this method here. And then just quickly, we want to tell kind of give reference of how big our viewport is in 3 dimensions. Because let's say we don't want to load all of our objects, so if we're like this close, we want the square to load, or a triangle I should say, but if that goes far enough out of the screen, we're just gonna not let that render, so we're gonna save some performance. So we need to set like how far in the Z direction we want our object to be seen. How we do that is we're going to say GL frustrum F as in float, and what we're going to do is we're going to say for the left value we're going to say our negative ratio that we set up, our right value our ratio, our bottom we're going to say -1, for top value we're going to say just for example 0.5. Our near Z is again the Z direction, how big we want that box to be that loads stuff within it. So we're going to say 1. This is going to basically be from the reference of where our camera's at. So it's going to be 1 is the starting point, and how far away from the camera is what we want the Z far to be. So we're going to set that to like 25. So if our camera gets 25 away, then it's going to not load it. And we just have to say this is a float value here, and there we go. So basically what this frustrum is doing is it's telling the left value, the right value, bottom and top, all that good stuff. And again, the left value we're using the ratio because again, if we switch from landscape to portrait, we want to kind of have that left and that right value the same according to which view we're in. So that's why we set up that ratio as well. And actually, I'm sorry guys, but we'll finish this up in the next tutorial because I know it's getting kind of long. I just want to give you guys again a quick overview of what we've done within this on surface changed. Again, we just set our viewport, so basically our whole screen is going to be our viewport, or our whole activity I should say. And again, it's starting with GL. The bottom left corner is the 0, 0 position, and unlike when we did like the canvas drawing, which the top left corner was 0, 0. So keep that in mind when you're working with GL or OpenGl. And then what we did is we set up a ratio to kind of handle what happens when the person changes their phone from portrait to landscape, and we're going to use this ratio later to define the frustrum, which is going to be basically our viewing area where it's going to load all of our shapes or triangles or whatever. And if it goes out of this kind of box surrounding those triangles, then it's not going to be able to see. We'll get into that later a little bit more in depth in the next tutorial when we actually see the triangle. I said we'd do it again in this tutorial, but that's probably going to be it for now. So watch the next tutorial, and I promise you guys we'll render it in there, and I'll catch you guys then. Have a good one. What's up guys, welcome to your 178th Android tutorial for the new Boston. What we're going to do in this tutorial, we're basically going to draw our triangle to the screen. Well, we're actually going to look at our triangle because it's already drawn there, we just have to find it. And in the last tutorial, again, all we did is we just set up our viewport, we set up like where we want it to be visible and all that good stuff. And now we're actually going to basically tell our camera to look at a specific point. And we also want to set it to model mode. So what we're going to do within our onDraw frame is after we call the clear method, we're just going to say gl matrix mode again. Oops, gl matrix mode, and this time we're going to set it equal to the gl10 class dot gl underscore model mode. And then what we're going to do is we're just going to call that load identity method. So we're just going to say gl load identity. And now what we have to do is we have to tell our camera where we want it to be in 3D space and which direction we want it to look. So how we're going to do that is we're going to refer to a class called GLU, and we're just going to say .glu look at, and the first parameter it just takes in which GL object we're looking at, GL10 object. Again, that's what's being passed into our class. And then we have to set where we want the camera, where the eye level is going to be. So what we're going to do is we're going to say we want it to be on the x-axis, so we're just going to set that equal to be 0, the y-axis 0. The z-axis, we're going to pull the camera back into basically us, not into the screen but away from the screen. So we're going to say like -5 or something like that. Then we have to tell it where we want it to look at. Again, our triangle was pretty much in the center, so we're just going to say 0, 0, 0. Basically the origin of our 3D space. And then what we're going to do is we're going to set our up values to 0, then like 2, and 0. Something like that. And now when we render it, it's basically setting our camera up again at this position 0, 0, -5, and it's looking in this direction. And you know, that's how we kind of set it up, and then we're going to draw our triangle. So let's make sure it works real quickly. So as you can see, it kind of looks a little bit off, but that's fine for now. And I kind of wanted to just show you guys that example because we set up our frustum a little bit differently than we should. Right here we've kind of skewed our bottom and our top a little bit. So just to change that, we're going to change this to 1. So we have a -1 bottom and a +1 top. And now let's render it and see how that looks. So again, OpenGl, you can kind of render stuff pretty much however you'd like. You can set up the camera, you can set up, you know, the perspective that it's at, all that good stuff. And it's pretty, you know, pretty impressive. And there we go, we have a better rendered triangle where it's not kind of skewed and it's not, you know, up higher, it's kind of more balanced in the center. So there we go, it looks a little bit better. So I'd recommend you guys just playing around with some of the values that we set up and see if you can get looking the way that you want. Again, we can move our let's say we want to move our Z value back to -10. That'll kind of look like it's scaled down, or you know, we're further away. And just quickly, I want to show you one more render for this tutorial, and then we'll either get into texturing this triangle or we'll get into 3D programming with a square of some sort. And as you can see, again, we're zoomed further back out. Before we were at -5 and now we're at -10. And again, we set up this Z value to refer to anywhere from, you know, 1 away to 25 away. So if we went up to like -24, or you know, even let's go -30, it won't even appear on our screen. And as you can see, when we're at -30, it's not even appearing on our screen because that's of the frustum that we set up. We only had it within, you know, 25 away. So if we did something more like, you know, -23, it's going to be really small, but at least we can still see it. But if we move further than that frustum value that we set up in our Z direction, Z far, then, you know, it's not going to render if we go further than that distance. So there's a little bit more explanation on the frustum, and see that now we can still see the triangle is far away, but if it goes any further back, or you know, actually it could probably go 1 further back, but if it goes further than that, it's just going to not even render that triangle, and we aren't going to worry about it. So that's kind of what the frustum did that we set up in the last tutorial. Again, we're just setting our camera here so we can even change perspectives, you know, like moving up 5 as well or something like that. Again, I just play around with the values, get comfortable with these commands and these methods that we set up, and try and render it the way that you'd like. But we'll get into some more methods, what we can do, how we can like rotate around this object and all that good stuff. As for now, we're probably done, and we're going to start building our cube, I'm guessing. So I'll see you guys then. Have a good one. What's up, guys? Welcome to your 179th Android tutorial, where we're going to start programming our cube. And what I've done is I set up 3 new classes. You guys don't have to, just so I can, you know, add it to the demo application that you guys can download from the marketplace or whatever. So it's pretty much the same. All I'm going to do is change, if you guys decide to make 3 new classes. I called this one GL Cube Example, which is the activity class, and it's going to take a GL Cube renderer, which is pretty much the exact same as our previous renderer, except instead of having a triangle, I set up a GL Cube, which we're going to create here, which is that class we're going to create for cube, and pretty much everything else is the same. It's giving us an error because we don't have a draw method within our cube as well, but pretty much everything else is going to be the same as for now. Maybe change this to be a little bit closer there. Alright, so let's get into it. Let's open our GL Cube class up, and it's right here. It's going to be pretty simple. We're actually going to we're going to open our triangle class first and pretty much copy everything because it's pretty much the same framework. So it's going to be nice and easy here, a little bit easier. We'll be able to move a little bit quicker than we did previously, and we just need to change our constructor to cube. Oops. To the name of our class, our cube here. So GL Cube. And there we go. Now let's just think about the points that we need to set up, and we're going to work with 3D now. It's going to be pretty much for the same same concepts here. So as you can see, we have 4 points here, and then also if we hover around, you can see 2 or 3 more points here, but there's also a 4th point back here. So we have a total of 8 points to build a cube, which makes sense. And so we're just gonna put those points in. Got to think about it. This would be like, let's go to the front view again. This frontmost point up here would be 1, 1, and then -1 in the y direction, or in the z direction. So it'll be closer to us. And then anyways, we're just going to program them. Hopefully you guys kind of understand the coordinates of the points. And so we're just going to go into Eclipse, change your point references up here. So we're going to say the first point will be 1, comma, that's in the x direction, 1 in the y direction, and -1 in the z direction. And we can just leave a comment. We'll say 0.0, and this is reference to the top, front, right? And then it depends how we're going to put these together, but when you guys are setting up your points, you kind of have a reference to how you label them, because again, we did clockwise last time, but we're just going to set them up and kind of wing it as we go. So the next point, we're going to do the bottom, front, right. So we're just going to say 1, -1 in the y direction, and -1 in the z direction. So we're going to call this point bottom, front, right. Next point, we're going to say the bottom, front, left. So that's going to be -1 in the y, or in the x direction, -1 in the y direction, and -1 in the z direction. And again, we're just going to call this point 2, bottom, front, left. Then we're going to set up the top, front, left as well. So we're just going to say -1, 1, -z axis, and that's going to be 0.3. And then we're going to just set these up as the back, and they're pretty much going to be in the same position. So I'm just going to copy this whole thing and paste it, and this time we just want to change the z to +1 instead of -1. And then we're just going to change all these fronts to back. And there we go. We have all of our points set up. We might want to change our references because we're going to get into that in the next tutorial, how we can connect these pretty much the most efficient way, so we don't have to do a whole lot of typing. And again, we're going to use this indices array here, this index array. So I'll catch you guys then. Again, pretty much the same concepts, except we just had a third dimension there, which we're going to have to change within our draw method and all that great stuff. So I'll catch you guys then, and have a good one. What's up, guys? Welcome to your 181st Android tutorial for the new Boston, and 180th Android tutorial for the new Boston. What we're going to do is set up our indices. So what we need to do, I created this little kind of reference so we don't get too lost here. But here's our square, and what we want to do is we want to create 12 triangles because each surface, like the front surface of the square, we're going to split it in half like this, so we have a triangle here and a triangle here. I just showed kind of a reference. So as you can see, that's how we're going to build our cube here. I keep saying square for some reason. I don't know why, but we're building our cube here with all these different triangles, so there's going to be 12. So let's just get going here. Again, we have to remember how we set up our front face. Even though we didn't really use it in the last time we built our triangle, I'm going to show you why we want this front face, just again to save some performance here. So we're going to go clockwise. So let's just get started with our indices. I'm going to delete these and just kind of create a new line here. And let's just develop this little chunk here first. So again, we're going clockwise. So we're going to start at 0.3, then 4, then 0 to create that top triangle. So 3, 4, and 0. Oops, did I do that right? What am I saying? All right, 3, 4, and then 0. That's going to be our first triangle, again, that's going clockwise, that's what we want. And then let's create this reference here, so it'll be 0, 4, and 1. Again, that's clockwise as well. So 0, 4, 1, and then let's give us some more space here and develop the last side of that chunk, and that one's going to be 3, 0, 1, again going clockwise. So 3, 0, 1, and then we're just going to go to the next line. So we know that we got that chunk done, and again, let's just do this one here. So we want the front again to be clockwise of this top half, so we're just going to go 3, 7, 4. And this is what I was talking about being tedious here. I thought we could use triangle fans, that's why I kind of broke it up like that, but Android doesn't support a function that I thought they did for OpenGl. But anyways, so we have this top surface done, and now we want this back surface, so that'll be 7, 4, 6, and that'd be clockwise, so the front would be facing the inside of the triangle. So we actually want to go, the opposite direction. So it'll be 7, 6, 4, and that'd be counterclockwise the way that we're looking at it. But when we go to the back of the square, it'll be, clockwise. So again, we want to go in this direction, so 7, 6, 4, something like that. And then let's give us some more room to create the side. Again, we just kind of have to think about which side we want to be the front or facing the front that we can actually see. So again, we're going to use these 3 points, and we want to go clockwise, so it'll be going in this direction. So it'll be 7, 3, and then 6. And then we're done with basically these two chunks here, and we're just going to work with this one now. So we're going to say again clockwise 3, 1, 2. And for the bottom, so if we're laying on the ground looking at this, we want to go clockwise again, so that'll be 1, 6, and then 2. And we're almost done, guys. Don't worry about it. And then we got to also do this surface over here. So we're gonna say 6, 3, 1. And as you notice, like, it doesn't exactly matter which order we do the triangles. There's different combinations that will still be clockwise for that specific triangle. But you want to make sure we're going clockwise, and I'll show you why in a second. And what's our last one? We have to do this one over here. So again, we're going to do 1, 4, 5, and that's clockwise as well. So we got that surface done, and then we want the bottom. So we're going to go 5, 6, 1. And if I messed up on some of these, I don't know if I am or not. I think they're clockwise. I'm just really tired, so I might be wrong here. But I'll show you that as an error, and why we're getting errors if I did mess up. And then just our last triangle here finally is the 4, 5, 6, and that'd be clockwise in this direction, but we want to look at it from the back view, so we're going to go 6, 5, 4. Alright, and we're pretty much done with our indices. As you can see, it was kind of tedious. Sometimes you just have to do some boring stuff, but there's our 12 triangles to develop our cube, and I'll wrap this up in the next tutorial. Hope to see you guys then, and have a good one.